Well, at T-minus 6 seconds, main engine was starting, and shortly at T0, we started the 50th mission of the Space Shuttle. Once we're clear of the tower, we began our roll maneuver, which puts us in the orbital plane that our mission would be in, and that was 57 degrees of inclination. And shortly after liftoff, we reached 20,000 feet, and already by then we're at Mach 1, and you'll be able to see some of the shock waves off the external tank and solid rocket boosters. And not much longer after that, about 2 minutes into the flight, we've used all the energy we can get out of our solid rocket boosters, and we separate from those. And now we're only on the main engines for another 8 minutes.
Once we got up, we turned our rocket ship into a spacecraft by opening the payload bay doors there and got ready to activate that laboratory you see in the bay.
And heading down the tunnel, the more I look at this picture, it's kind of like taking a subway to work here. It's about 20 feet long, and it's fun to go down. You just give a push off at one end. You have to make a little jog as you go into the lab here, and you can see you got to stick your hand out to stop a little bit. But once you're in the lab, we started activation. We got back there about 3.5 hours into the mission, and the activation went very smoothly.
Yeah, Redshift started working on a material science experiment. This is a crystallization experiment using image mirror furnace. And I became also a subject of 4 different Japanese experiments. This is a perceptual motor function experiment using a joystick. And in those experiments, scientists on the ground checked my eye movement while I attempted to track the flickering light.
Twice a day, of course, we would hand over the vehicle. We were working a dual shift mission. We had the red shift and the blue shift, so in the morning we'd hand over from blue to red. In the evening we would hand over from red to blue, handing over both the orbiter functions and the space lab.
On the blue shift, we did the free flow electrophoresis experiment, which is a Japanese experiment. We're passing electrical current through some biological materials to separate them out according to their electric potential. We had 3 of these experiments scheduled, and we were able to do 2 extra ones during the flight. So we feel like we had a really good experiment there, very successful, even though we did lose some of the downlink data.
One of the experiments that you've heard a lot about was lower body negative pressure. And these are just images from the lower body negative pressure. The objectives of that experiment was to really see how the heart adjusts to microgravity and to figure out, can you use lower body negative pressure as a countermeasure to help people to readjust when they come back. Some of the other experiments that we did that dealt with medical issues were a fluid therapy system. The fluid therapy system we used really talked about can you produce IV fluids in space and whether or not you're able to successfully administer them. But we did spend a lot of time working with lower body negative pressure, and we got lots of results back, good results back.
While the Space Lab crew was busy working back in the lab, the orbiter crew was also busy on the middeck. We had several experiments that we ran. One of these is the protein crystal growth, which we see here being activated once we got on orbit. Another experiment we had going was a medical data take of energy utilization, and we collected some blood samples, tested for glucose, and we logged all the food and water, and some urine samples we took to better understand how the body actually uses the food that we intake while we're in a zero-G environment.
The first thing I had to do in the morning right after I woke up was to attach 3 different electrodes on my body. Except the 4th and 5th days, I wore all the time a backpack called PMS, and to monitor my electrocardiogram and vertebral wave and skin conductance level. Every day in the afternoon, I wear this, and I spent a couple of hours to conduct cell culture experiment using a specially designed culture kit and optical microscope. We mainly observed how cells are developed under micro G and took many microscopic pictures.
I'm not sure if we had a record number of in-flight maintenance procedures, but we did have some fairly critical ones. Early in the mission, we had a water leak in the material science rack, and we went in there, and it was a fairly simple thing to fix once we took the insulation away. It was similar to just fixing a leaky faucet at home, but it kept the loop intact, and we were able to continue with furnaces such as this, which is the image mirror furnace. It was one of the funded projects to work on orbit because it was rather interactive. You had to establish a melt zone. In this particular scene, we're putting a quartz tube around the sample, and then once we got the image mirror closed, we went ahead and brought the samples together. And we bring them together so that the focus of there's a light bulb in the back and also one in the cover. The focus of the energy is on the gap between the two samples. This was one of them that we did. We did two other experiments in the image mirror furnace. One of them was a glass cube experiment. This glass cube, the objective was to turn it into a glass sphere and do some measurements. In this particular case, the temperature got a little bit higher than we expected. And I guess it's one of the reasons that you do experiments, to try to understand the reaction to certain materials in zero gravity. And the other one that looks like it's very successful was our samarskite sample. We have a sample here that's about, I guess, 6 to 8 millimeters long.
In addition to the image furnace, we also had some other major furnaces in the two material science racks. We had 4 other major furnaces, including this one, which was a continuous heating furnace, which had 2 heating chambers and 2 cooling chambers. Of course, we also had the large isothermal furnace and the gradient heating furnace, as well as our acoustic levitation furnace, which we're able to conduct our experiments because we had the water leak fixed in the material science racks, for a total of 22 material science experiments.
We had a couple of audio dosimeters that we kept in place in different parts of the orbiter. Every time I came back to do one, the payload commander accused me of coming back to perform pilot science. So this is a little bit of pilot science that we're seeing right here. And this is a study in angular momentum. And of course, we're all familiar with the way an ice skater starts out with their arms out and retracts their arms to increase the rotational speed, and our pilot is here checking it out to see that it does in fact work in weightlessness. This spooled him up pretty good. Watch his eyes when he finishes.
That's okay.
We had a relatively new piece of gear on board, the bicycle ergometer, and this is really a wonderful contraption, and we were able to use this up on the flight deck, and it's quiet enough that we're able to exercise during sleep periods.
Well, after a busy day of doing experiments and working out, we headed for the galley, and the chow up there is really pretty good. Here's Mark making a meal, and we were very fortunate to eat early and often during this mission, and we all liked it. And we found chopsticks up there are pretty practical in zero G, although you'll notice our Japanese payload specialist is having cross-cultural experience. He's the one using the spoon. But we found curried rice up there was superb, and I'm going to recommend taking it as a standard item. Chopsticks were real good for most of the foods we ate up there, but not for all of them, so we used other techniques for certain foods that we ate there. And here you'll see it getting ready to get dark up there, which of course it did 16 times a day, and it gets dark in a big hurry, as you're just about to see out the window there right behind Kurt.
Just like on Earth, you have certain personal hygiene things you must take care of. This is the red shift, getting up and getting ready to go to work for a day, and doing a little teeth brushing there and washing our hair. And our commander, you know, you can only do so much with what you got to work with, but he's doing his best here. And it's actually pretty easy in space. You don't have to find a wall to hang your mirror on. You can kind of just let it hang around. But he's working away there.
Takes a little while to get ready in the morning.
I understand that 4 members of our flight had a lot of interesting publicity down here. The frog embryology experiment was one that I think was very successful. We took 4 female frogs up. We gave them human chorionic gonadotroph and caused them to ovulate. We're able to actually have over 100 live tadpoles that were brought back that were actually conceived and born in space. The experiment went very well. The results now, the investigators are out at Ames Research Center working busily on things, but very generally, the gross appearance of the tadpoles that were conceived in 0G looked very normal. They seemed very normal. So it was a good experiment. One of the things we also wanted to look at was what was the behavior? Was there a problem with their tadpoles' interpretation of what goes on in 0G? Can they swim normally? So we actually took up tadpoles that were hatched here on the ground and watched their swimming behavior. Some of the things it seemed like is that they had a difficult time figuring out which way to swim, as you can see, so they swam in circles. But we're able to bring tadpoles back down and also observe their behavior.
We also did our studies on the blue shift of angular momentum, and since I am an ice skater, it was kind of fun to play with pulling my arms in, going faster, and then putting them back out and slowing down. We also had fun with other things and watching the physics of how they behave when we spin them around. Those are pair of pliers.
Jay is using Sorex, which is amateur ham radio equipment, to communicate directly to the people on the ground. We contacted many schools around the world. Here, we flew over Japan. It was very impressive for me to see my hometown from space. This is Hokkaido, just we saw, northern island of Japan. Sapporo is the capital of the Hokkaido, where I used to work. Now, most of the time when we flew over Japan was cloudy, but I had one time to see a Tokyo metropolitan area. I was very much impressed that Tokyo Bay was very clean, as you see there.
This is Hurricane Bonnie, which was about 500 miles north-northeast of Bermuda when we took this photo, and you can see the spiral bands around in the well-developed eye. It's a classic hurricane. Just after that, we got ready to check out the vehicle for landing, and here we are checking out the elevons during what we call the flight control system checkout. You can see them moving back there on the wing in this wide-angle view. And we were well satisfied the vehicle was ready for entry, and so was the ground.
Well, after a very successful mission, it's time to come home, even though we got an extra day. So we had to prepare the vehicle for entry, got in our suits, got all strapped back in, made our deorbit burn, and that was very successful, and we're on our way home. This is a view out my window. We're in the red is a glow from entering the atmosphere, the excitation that orbit does, and you can see the sunrise. We're in a big right bank at that point. Back in the lower atmosphere, with the Thuot flying here, we are starting to get some tips off the wings, and then doing some more checking. We'll be in our right turn here on our heading alignment circle, preparing to roll out on final to complete the landing phase. The orbiter, as you see, looks like it's a very nice flying aircraft. It looks very happy in that environment there. On the ground, it looks like it's falling like a brick, as we probably all know.
We had a lot of concern about the weather at the Cape and being able to get back in there, but as you can see, we had just an absolutely beautiful day to come back to the Kennedy Space Center.
Here's Thuot rolling out on final, and shortly you'll see him put the nose down a little bit. We'll pick up some more airspeed and prepare for the final landing phase. I got to fly the orbiter for a few seconds on entry, and thanks to Thuot, and the orbiter flies very nicely. It flies like a much smaller aircraft than it really is. Very nice handling machine. A view from the vertical assembly building as we come in. You can still see the moisture off our wings. Getting ready. My primary job in life now is to put the gear down. There comes the gear. And here's the commander coming in for a very, very spectacular landing. Hit all the parameters that we're looking for as we come in to land. Very nice touchdown. We touched down at 205 knots, and shortly after that we were calling out airspeed. We're looking for 175 knots, and at a point I got to deploy the drag chute. We were the first to deploy with the nose still in the air, a test that we were doing to hopefully expand the envelope. And then the nose touched down about 130 knots. Approaching about 60 knots, we've gotten about all we could out of the drag chute, so we go ahead and jettison, and then we let the orbiter roll to a stop, like in the previous missions.
As I mentioned, this was the conclusion of a very successful mission. We had just one redshift handover, one redshift tag up left to make, and this is Kurt and I having our final redshift tag up just after we'd rolled to a stop.
Down the tunnel, the more I look at this picture, it's kind of like taking the subway to work here. It's about 20 feet long, and it's fun to go down. You just give a push off at one end. You have to make a little jog as you go into the lab here, and you can see you got to stick your hand out to stop a little bit. But once you're in the lab, we started.
Puts us in the orbital plane that our mission would be in, and that was 57 degrees of inclination. And shortly after liftoff, we reached 20,000 feet, and already by then we're at Mach 1, and you'll be able to see some of the shock waves off the external tank and solid rocket boosters. And not much longer after that, about 2 minutes into the flight, we've used all the energy we can get out of our solid rocket boosters, and we separate from those. And now we're only on the main engines for another 8 minutes. Well, at T-minus 6 seconds, main engine was starting, and shortly at T0, we started the 50th mission of the Space Shuttle. Once we're clear of the tower, we began our roll maneuver.
Once we got up, we turned our rocket ship into a spacecraft by opening the payload bay doors there and got ready to activate that laboratory you see in the bay.
And